Hello friends, welcome to Independent Learning. My name is Raj Shah. In this video, we are continuing with the chapter quadrilaterals. Okay. In the previous video, we saw what a quadrilateral is, and we also saw how quadrilateral is the parent name. Okay, for all the parallelogram, rectangle, and square. Okay. So in this video, and also we saw questions based on parallelogram. Okay, the two theorems. Based on two theorems, we saw questions also. Okay, in this video we are going to discuss some theorems on parallelogram. Okay, so we'll be discussing all the theorems whichever is there based on parallelogram, okay, in your syllabus in this video itself. Okay, so let's get started. Okay, so here the first theorem, it says opposite sides and angles of a parallelogram are congruent. So you already know that what is a parallelogram. Okay, which says that if opposite sides, okay, opposite sides are parallel, oh yes or no. So this is the proof for parallelogram. If it is a parallelogram, we have to prove that opposite sides and angles are congruent. That means, that is to, okay, let's write what is given to us. What is given here? ABCD is a quadrilateral. So we'll say ABCD is a quadrilateral. Yes or no? Okay. So ABCD is a quadrilateral. Okay. Oh, sorry. Parallelogram. Correct. And if it is a parallelogram, we can say AB is parallel to CD and BC is parallel to AD. Yes or no? So all the opposite sides are parallel. Now, what is to be proved? We have to prove that opposite sides and angles are congruent. That means we have to prove angle A should be congruent to angle C, angle B should be congruent to angle D, that is opposite angles. Then if you see opposite sides, that is AB should be congruent to CD and BC should be congruent to AD. Correct? So this is what we need to prove. Now, before starting with the proof, we'll do a construction, which is drawing a diagonal. Okay, so we'll do a construction which says draw AC. Okay, or you can say draw diagonal AC. Now let's start with the proof. Okay, so let's try. So we have already done this in triangles. Okay, we have to prove that the opposite angles, these two angles should be congruent, these two sides should be congruent. So to prove that their sides and angles should be congruent, we have done this in triangles, that if you want to prove triangles or sides to be congruent, try to prove that the two triangles are congruent. If we are able to prove, then by CSCT and CACT, we can say that the opposite, the angles or the corresponding sides are congruent. Yes or no? So let's try to prove the two triangles to be congruent. Okay, let's consider triangle ADC and triangle CBA. Okay, so we have considered this and this triangle ADC and CBA. Correct. Now if you see this AC and AC, if you see AC and AC, they both are same in both the triangles. So can we say AC is congruent to AC itself? Why? Because common side. Correct. And now if you see this this side, okay, CD and AB, so they are parallel. And if you see AB and CD is parallel, so we are getting something like this, AB CD. Correct. And AC is the transversal. Correct. So this is how it is happening. Yes or no? So can we say that this angle and this angle, they both are congruent? Why? Because alternate angles test? Yes or no? If two lines are parallel and there is a transversal, then we can say that the alternate angles are congruent. Yes or no? So we have done this in parallel lines. So if you are not sure about this, go back and check the video on this. Okay. So we'll take this directly. So here on this we can say angle DC. So this angle and this angle. So angle DCA. So DCA is congruent to angle CAB or BAC. Correct? So these two angles are congruent. We can say the reason as alternate angles test, or we can say AB parallel to CD and AC is the transversal. Okay, yes or no? And alternate angles test. Correct? So I hope you have understood this. Same way, can we say that this angle and this, this angle. Can we say these two angles are also congruent? Why? Because these two are parallel. So we can say BC parallel to AD, and so BC is parallel to AD and AC is the transversal. Okay, so AC is the transversal. I've written this in short, transversal. So this angle, so again it will become like this, then this, then this. So if you see, this is D, this is A, this is C, and this is D. Yes or no? So this angle and this angle, they both will be congruent. Same way, so we'll write that here. DAC, so DAC and BCA. Correct? So these two angles will also be congruent by alternate angles test. Yes or no? So what we have got, two angles congruent, one side congruent, therefore we can say triangle ADC and triangle CBA, they are congruent. Yes or no? By ASA test. So okay, so I hope you have understood. So we prove this triangle, okay, this particular triangle and this particular triangle to be congruent. Yes or no? So here, can we say that AD will be congruent to BC? AD congruent to BC? Yes or no? That's what we need to prove, right? AD congruent to BC and CD congruent to AB, or AB congruent to CD. Yes or no? So it's better if you write CD congruent to AB. Why? Because CD is in this triangle, so CD first, then AB here. Okay, so this is what we get. Opposite sides we have got as congruent, and the reason for this will be CSCT. Yes or no? Now, can we say this angle and this angle are also congruent? Yes or no? So we can say angle ADC is congruent to angle CBA. Yes or no? By CACT. Yes or no? So can we say that angle D and B is congruent to angle D? Yes or no? Same angle but different name. Or you can write D then B. So it's up to you. Yes or no? That's what we get. Therefore, with the help of this, we can also say, so we have taken these two triangles and we have proved these two angles to be congruent. Now take these two, okay, draw this diagonal, okay, and try to prove A and C to be congruent. So if you draw this, okay, this as the diagonal construction, we can take these two triangles and try to prove these two triangles to be congruent similar way, and then we can say that C and A are also congruent by CACD, just like this. So we can similarly we can say, so similarly ka sign is three parallel lines and then ly. So similarly we can say A congruent to C can be proved. Okay, so I hope you have understood. So we have proved that opposite sides and opposite angles are congruent. Okay, so that's what the theorem says. Okay, which says opposite sides of a parallelogram. So if it is a parallelogram, then opposite sides and angles are congruent. Okay, so this is the theorem. Now there is a converse on this. Okay, so that is it is called converse because it is ulta of this. Okay, and converse theorems, they are called test for parallelogram also. Okay, that means we are checking whether the given quadrilateral is parallelogram or not. Okay, so just see, let's see the converse. So here it says opposite sides and angles of a parallelogram are congruent, but the opposite of that will be, if pairs of opposite sides and angles of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So if you have not understood, you can see the first chapter, basic concepts in geometry, the third lecture, okay, on converse conditional statement. So you'll be able to understand how do you write the converse of any statement. Okay, first you write the given statement in if then form, that is conditional, and then we can write the converse of it. Okay, so if you're not understanding what I'm saying, go check that video on basic concepts in geometry. Okay, and then you'll be able to understand how to write the converse of any statement. So let's see this theorem, which says that if pairs of opposite sides and angles of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So it is just converse of this. Okay, but we'll try to break this into two. We'll first prove that if pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram, and then we'll also take if pairs of opposite angles. So the converse, there will be two theorems on converse of this particular statement. Okay, so I hope you have understood this. So on this there are three theorems. One is this, then converse of this is one on sides and the other on angles. So let's see that. Okay, so we are looking at the converse of the previous theorem. Okay, so here it says there are two converse. One it is about sides and one about angles. Okay, so first we'll discuss about sides. It says that if pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So there is, sorry, okay, so there is a parallelogram given to you. Okay, PQRS, and we are taking, okay, first of all, before taking this is the construction, and what is given to us? Let's write that first. So what is given here? Opposite sides of a quadrilateral are congruent. That means PS is congruent to QR, correct? Then PQ is congruent to SR. Yes or no? So opposite sides are congruent. Then what are we supposed to prove? We are supposed to prove that this is a parallelogram. So to prove quadrilateral PQRS is a parallelogram, correct? So here we'll do a construction which says draw diagonal PR. Okay, So I hope you have understood this so far. We are constructing this diagonal which is PR. Now let's start with the proof. Okay, so we are trying to prove that this is a parallelogram. That means we have to prove that opposite sides are parallel. Yes or no? That means you have to prove PS should be parallel to QR and SR should be parallel to PQ. Yes or no? So in order to prove that the opposite sides are parallel, can we try to prove that the alternate angles are congruent? That is this angle and this angle, correct? Sorry, this angle and this angle, they are forming what? Alternate angle. So we'll first prove these two angles should be congruent and also this angle and this angle to be congruent. If we are able to prove that by converse of alternate angles test, we can say that this line, okay, these two lines and these two lines, they are parallel to each other, opposite side. So this becomes opposite sides to be parallel. Yes or no? So let's try to prove that. So we'll take these two triangles first, try to prove these two triangles to be congruent. Taking in triangle SPR and triangle QRP. Okay, so we are taking these two triangles. So we'll try to prove that. So let's see how we do it. So here PS is, so from this, so from SPR triangle, SP is congruent to QR, which is given. Yes or no? So this is given to us. Then in SPR, okay, SR is congruent to PQ. So we'll say that also SR is congruent to PQ, which is also given. Yes or no? And can we say PR is congruent to PR itself? Why? Common side. Yes or no? So because of this, so all three sides are congruent of a triangle. Therefore we can say triangle SPR is congruent to triangle QRP. Yes or no? So these two triangles are congruent by SSS test. Okay. So we are able to prove these two triangles to be congruent. Now we can say, so what can we say from this here now? So this triangle, so from this triangle, can we say SPR? So therefore angle SPR, okay, SPR and QRP. So QRP, so SPR and QRP, they are congruent. Yes or no? Why? Because CACT corresponding angles of congruent triangles. And can we say that SRP, so SRP is congruent to QPR. Yes or no? So SRP, so from this itself we can figure out SRP is congruent to QPR. Again by CACT. Yes or no? So we have got the alternate angles to be congruent. Now for this, okay, for SPR and QRP, can we say if these two angles, okay, are congruent, and so SPR and QRP, so these two, and PR is the transversal. So write this first, or I'll do it once again. So we can say therefore angle SPR is congruent to QRP and PR is the transversal, correct? So if this and this is congruent and this is the transversal, aren't we getting like this? This and this S, this is P, this is R, and this is Q. Yes or no? So we're getting these two angles to be congruent. See? and PR is the transversal. Therefore, can we not say PS is parallel to QR? Therefore, we can say PS is parallel to QR. Correct? This is what we get. So we can say this by converse of alternate angles. Yes or no? So converse of alternate angles. Okay, so I hope you have understood this. The next thing about this, so we can draw it like this. This is Q, this is P, this is star and star, S and R. Correct? So with the help of this, we can say again, angle SRP is congruent to QPR. Yes or no? SRP and QPR and PR is the transversal. Yes or no? Therefore, again by alternate angles test, we can say that these two sides are parallel. So we can say PQ is parallel to SR. Okay, again converse of alternate angles. So from this, these two, we can say opposite sides are parallel. Therefore, from 1 and 2, let's name this as first equation, this as second equation. So from 1 and 2, we can say quadrilateral PQRS is a parallelogram. Okay. So I hope you have understood this. Okay. Now we'll take the other converse, which is considering if pairs of opposite angles of a quadrilateral, okay, if they are congruent, then their quadrilateral is a parallelogram. So let's see that. So here this is the other converse, which says if pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay. So what is given here for us? So what is given, let's write, or let's write it from here. So what is given here for us? Opposite angles are congruent. That means in quadrilateral EFGH, angle E is congruent to G and F is congruent to H. Correct? Opposite angles. Yes or no? So this is what is given to us, and what is to be proved? To prove that this quadrilateral is a parallelogram, that means quadrilateral EFGH is a parallelogram. This is what we need to prove. Correct? So let's start with the proof. Okay. Now this E and F, okay, let's say, so this is forming a quadrilateral. Can we say angle G equal to angle E is equal to X, okay, and keep F and H as Y, correct? So keep these two, G and E, they both are congruent or equal, we can say. Keep them both as X and these two as Y. Now, if this is a quadrilateral, you already know that sum of the angles of a quadrilateral is 360. Therefore, we can say angle E plus angle F plus angle G plus angle H is equal to 360 degree. Why? The reason for this will be sum of the angles of a quadrilateral is 360. So you can write that reason. Sum of angles of quadrilateral is 360. Okay. So this is what the reason is. Therefore, now can we substitute, instead of G and E, we can substitute X, and instead of F and H, substitute Y in this. So we can get E and G, so X and X. So we get X and X. And for F and H, we substitute Y. So Y and Y equal to 360. Yes or no? Now, from this, X to 2x plus 2y equal to 360. Yes or no? X plus x is 2x, y plus y is 2y. Now 2 into x plus y equal to 360. Yes or no? Taking 2 common and then dividing this 2 with 360, so we get equal to upon 2, so this will be x plus y equal to 180 degree. Yes or no? So we have got x plus y as 180 degree. That means substitute g and h. So let's keep x as g. So this will be g plus h. Let's keep y as h equal to 180 degree. So we have just resubstituted it. Okay. So we get g plus h equal to 180 degree. Now from this, what do you understand? We can say this plus this. Yes or no? Angle G plus angle H. See, this is X, this is X, this is Y, and this is also Y. So from this, we get X plus Y equal to 180 degree. So we'll consider this and this. Yes or no? So if these two ka sum is 180 degree, can we say, okay, this is forming an interior angle? Yes or no? So we can say angle G and angle H are interior angles with, okay, with HG as the transversal. Okay, so therefore we can say that HE is parallel to GF. So if you remember, okay, when is these two angles interior angle? When, or you can say, when will these two lines be parallel? When the sum of interior angles is 180 degree. So we are getting this. So with converse of interior angle theorem, we can say that HE is parallel to GF. Correct? Yes or no? So with this, we can say by converse of interior angle theorem. Okay. So I hope you have understood this. So by converse, now same way we can also prove, sorry, HE and GF we have proved. So we can prove HG and HEF, or we can say consider x plus y here, right? So from here we can say angle G plus, instead of y we substituted h here, now we'll substitute f. So this will give us 180 degree again. Therefore again same way, interior angles, sorry, x and y, so these two are forming interior angles. Therefore these two sides are parallel. Therefore we can say HG is parallel to EF. The reason will be same, converse of interior angles theorem. Okay, so I hope you have understood. You can say the same reason. Okay, therefore if opposite sides are parallel, we can say that this is a parallelogram. Okay, so I hope you have understood this. Now we'll take some other theorems. Okay, so let's see them. Now we are taking another theorem and its converse. Okay, so this theorem says diagonals of a parallelogram bisect each other. Okay, that means if we have PQRS, okay, that is a parallelogram, and this is the diagonal QS and PR. So let's write also what is given to us, that diagonals of a parallelogram. So we have to say that PQRS is a parallelogram. So quadrilateral PQRS is a parallelogram that is given, and diagonals bisect each other. We have to prove. So first of all, let's say which one is the diagonal. So PR. So we'll say diagonals PR and QS meet at point O. Okay, so both the diagonals meet at point O. Okay, now we already can say, okay, this angle, sorry, not this. Okay, so what did I mark this? Can we say if this is a parallelogram, opposite sides will be congruent? If opposite sides are congruent, that means this is a transversal. Therefore, we can say that this and this, which is PSQR, always try to make these, okay, something like this, free body diagram I say. So if you are able to draw this, you will be able to understand what is happening in the quadrilateral. Okay, so this is an easy way to understand or to make you understand. So this angle and this angle, they both are congruent, and in between there is O. Okay, and same way this angle and this angle is also congruent. So we can name this PQRS. Okay, so from this, these two angles, two pairs of alternate angles are congruent. So you understand these two are what? Alternate angles. Yes or no? So let's start with the proof. Let's see. Okay, first of all, what are we supposed to prove? We never discussed that. So let's see. Diagonals of a parallelogram bisect each other. That is, this O should cut this diagonal into equal parts. That means to prove, okay, PO should be congruent to RO. Yes or no? Because O is the bisector. So I mean diagonals should bisect each other. That means cutting into equal parts. Means diagonal will be cut into equal part. So PO should be congruent to RO. That's what we need to prove. And SO should be congruent to QO. That is also to be proved. Okay. So let's see the proof now. At the start, let's try to prove these two triangles to be congruent. Okay, so take these two triangles, try to prove them as congruent. Then by CSCT, we can say that the opposite, I mean this side is congruent to this, and this is also congruent to this by CSCT. Okay, or you can also take these two triangles and consider the alternate angles for them, and then by proving these two triangles to be congruent, we can say by CSST these two opposite the diagonals bisect each other. So we'll do this way, okay, considering these two triangles. So we'll consider triangle POS and triangle ROQ. Okay, now we can say SPO angle SPO. So this angle is congruent to this. So write this clearly or properly. Okay, so SPO is congruent to QRO. Yes or no? What is the reason for this? Alternate angles test. Yes or no? Same way, can we say this angle to be congruent? So we can say PSO is congruent to RQO. Again, alternate angles test. Yes or no? And the last one we can say PS is congruent to RQ. Why? Because this is a parallelogram, and if it is a parallelogram, then opposite sides are congruent. Okay, so we can say that because it's parallelogram, therefore we can say that this is given. Or you can specify the theorem itself, which says that opposite sides of a parallelogram are congruent. Okay, so this is what we get. Therefore we can say triangle POS is congruent to triangle ROQ by ASA test. So okay, so this is what we get, and this is what we have proved now. So we can easily say, if we have proved these two triangles to be congruent, we can say PO is congruent to RO, and SO is congruent to QO, both by CSCT. Because both the triangles are congruent, we have proved already. So this and this is congruent, this and this is also congruent. Okay, that's what we have proved here. So that's what the theorem says. Diagonals of a parallelogram bisect each other. Okay. So this is what we have done. Now the converse of this says, if diagonals of a quadrilateral bisect each other, then it is a parallelogram. Okay. So here there is already a parallelogram. Diagonals are, if you draw, let's say A, B, C and D. Let's say we are drawing a diagonal, the two diagonals. Okay, now diagonals bisect each other. That means this and this, they are congruent, already given to you. Here we have to prove. Okay, that's why this is called converse. So this theorem says that diagonals are bisecting, and we have to prove that it is parallelogram. But this here, the normal theorem, it says that this parallelogram is already given to you, and we have to prove that the diagonals bisect each other. Okay, so I hope you are understanding the difference between them. Okay, so here we are proving that this is a parallelogram. So here the diagonals, they bisect each other. That means this and this is congruent, this and this is congruent. Okay, so with the help of this, we can easily prove that this is a parallelogram. Okay, how can we do this? Okay, we can take these two triangles or these two triangles, yes or no. So take these two triangles, let's name this as O. So AOD and COD we take. Okay, so by this side is congruent to this, then this side is congruent to this, so we have got two pairs. And then we can say AOD is congruent to COB, vertically opposite angle. So with this we can say by SAS test, these two triangles are congruent. So once we are done with proving two triangles congruent, we can say alternate angles are congruent. If alternate angles are congruent, then we can say that opposite sides are parallel. And if opposite sides are parallel, then this is a parallelogram. Okay, so I hope you have understood what I said just now. Okay, I won't be writing the proof for this. Okay, you are supposed to write this on your own. Okay, so we'll take the next theorem, or the last theorem on this video. Okay, so let's see that. So here, this is the last proof, okay, of this video, which says that a quadrilateral is a parallelogram, okay, if a pair of its opposite sides is parallel and congruent. So if you consider any one pair of opposite side, if they are parallel as well as congruent, okay, then this is a parallelogram. Okay, so what is given to us? So what is given here? Any one pair of opposite sides you have to consider first. So let's consider CB and AD. So we'll say CB is congruent to AD and CB is parallel to AD. Okay, so one pair we have considered, they are congruent, okay, as well as parallel. So if that is happening, then we have to show that this is a parallelogram. Okay, so let's try to prove this. So what is to be proved? To prove quadrilateral ABCD is a parallelogram. Okay, so we'll do a construction for this, for the proof. We'll draw diagonal BD. Okay, so we'll draw this diagonal. Done. Now let's see the proof. Okay, so in order to prove that this is a parallelogram, we already have this side and this side parallel. If we are able to prove these two sides parallel, then we are able to say that this is a parallelogram. Correct? Therefore we'll try to prove these two sides parallel. Okay, how can we do that? By proving alternate angles to be congruent. Yes or no? So our ultimate goal will be to prove this and this congruent. So by alternate angles test we can say AB is parallel to CD. Okay, so how do we do prove that these two angles are congruent? By considering these two triangles. Okay, so we'll consider two triangles. Triangle CBD and triangle ADD. Okay, let's consider these two triangles. Then we can prove that these two triangles to be congruent, which is CBD and ADB. So let's try to prove them. So already we have this and this CB and AD parallel. Yes or no? So if these two are parallel and this is the transversal, can we say this angle and this angle they are congruent? Why alternate angles? Because these two are parallel already given to us. It's like this. Okay, so this and this congruent. Now if these two are congruent, so let's try to say, we can say that CBD is congruent to ADB. Sorry. Okay, why? Because alternate angles test. Yes or no? Because parallels, the lines are parallel, therefore alternate angles are congruent. Correct. Now after getting this, we can say that this side, okay, one more thing, CB is congruent to AD given. CB is congruent to AD, which is given. Yes or no? And can we say BD is congruent to BD itself, common side? So we can say BD to BD itself, common side. Correct. So by SAS test we can say triangle CBD is congruent to triangle ADB by SAS test. Correct. So we have proved that these two triangles are congruent. Now can we say that this angle and this angle they are congruent? So we can say CDB is congruent to ABD. Why can we say this? Because CACT, because we have already proved two triangles congruent. So if we are able to prove these two congruent, then we can say this angle and this angle they are congruent. Now if this is congruent and BD is the transversal, therefore we can say that by converse alternate angles test we can say CD is parallel to AB. Yes or no? Why? And the reason can be converse of alternate angles test. Okay, I have not written it properly, but make sure that you write it properly. Converse of alternate angles test. Okay, so here we have got this one side parallel, one pair of opposite side parallel, and this is another pair. So we can say CB is parallel to AD. This is given. Therefore, if opposite sides are parallel, then this given is a parallelogram. Therefore, we can say quadrilateral ABCD is a parallelogram. Okay, so I hope you have understood this. Okay, so we did quite a bit number of theorems in this video. So this is it from my side on theorems of parallelogram. So in this video we took all the theorems on parallelogram, okay, which you have for your syllabus. Okay, so I hope you have understood the theorems. Okay, in the next video we'll be solving questions based on the theorems which we had not solved in the previous video. Okay, so I hope you have understood this video. If you have, then make sure that you share it with your friends. Okay, thank you for watching.